So guys, today in this video we are going to deal with a new chapter called as Aldehydes, Ketones and Carboxylic Acids. Aldehydes, Ketones and Carboxylic Acids. So first important question arises now within us. What is the main difference of this chapter with respect to the other two chapters we have read in the organic chemistry? Alva. So now we are going to see aldehydes, ketones and carboxylic acids. In the earlier classes of organic chemistry, first chapter we have dealt with haloalkanes and haloarenes. Yes. In the second chapter of organic chemistry, we came to know about alcohols, phenols and ethers. So what is the main difference between these three, if you ask me? Of course, in the first part, that is your haloalkanes and haloarenes, whatever the halogens were there, that may be your chlorine, your bromine, your iodine, so they were acting as a substituents. So that makes a difference. When compared to the second and the third, now what you are going to read, of course, they both are functional groups. Your alcohols maybe, your ethers maybe, your phenols maybe, aldehydes, ketones and carboxylic acid, they are the functional group. So of course, we came to know the major difference between first chapter, second and third respectively. But when we are comparing your second chapter with the third chapter, of course, the earlier explanation cannot hold good because alcohols are also functional groups. Even our aldehydes, ketones and carboxylic acids are also functional groups. And what is the major difference between these? Yes. So first and the foremost thing we have to understand about their functional group. How do we write it? Of course, when I say alcohols, what is the functional group you are going to write? Very good. That is OH. If I want to write the general formula for alcohols, I will write it as ROH. Yes. Ethers, of course, ROR. But when I am saying you to write aldehydes general formula, how will you going to write? Of course, RCHO. Yes. So when I am writing for ketones, how can I write? RC double bond O and an R. So when I am writing for carboxylic acids, RCOOH. So what is the main difference we can observe between your alcohol ethers and your aldehydes, ketones and carboxylic acids? Very good of that. So basically we are going to deal in this chapter a major important concept called as carbonyl compounds. What is that? Carbonyl compounds. So what is that carbonyl compounds? Of course, what you are seeing in your general representation. That is, a carbon atom has been bonded to the oxygen by a double bond. I repeat, a carbon atom has been bonded to oxygen with respect to the double bond. Such compounds are called as what? Carbonyl compounds. This group is called as what? Carbonyl group. Carbonyl group. So therefore, our aldehydes, ketones, even our carboxylic acids, they fall under the category of our carbonyl compounds. Is that okay? So majorly we have got the difference. Alcohols, ethers are also functional groups, but they are not the carbonyl compounds. But majorly when you talk about your aldehydes, ketones and carboxylic acids, of course they are also functional group. But what is the major difference? That they are the carbonyl compounds. Is that clear? Okay, now let us move forward. So basically when I am talking about aldehydes and ketones, particularly I had to make a difference between them. Because I know that both aldehydes and ketones are the carbonyl compounds. But how can we differentiate aldehyde from ketone is the major task. Remember guys, whenever we choose aldehydes, you should remember that, of course, it is a carbonyl compound. But what has happened, Of course, we know the carbonyl is having a tetravalency. Of course, by utilizing its 2 bonds, it has been formed with respect to of your oxygen. But remember, one more valency of your carbon in aldehydes will be satisfied with respect to that of your hydrogen. Are you getting my point? Among your tetravalency around your carbon, in order to be more accurate, I can say, the remaining 2 valencies, I repeat, the remaining 2 valencies of the carbonyl group, in that one valency will be satisfied by your hydrogen in our aldehydes. Whereas the another valency can be an hydrogen itself, it can be an alkyl group, it can be an aryl group. Alva. So what they are saying? In the 2 valencies, the remaining 2 valencies of our carbonyl group, in which one valency will be satisfied by our hydrogen particularly, whereas another valency can be accommodated by hydrogen itself, or alkyl group, or an aryl group. That means how? You can get the formulas when I'm writing H over here. H, C, double bond O, H I can write. When I write as an alkyl group, let me choose a CH3 group, CH3C double bond OH. Yes. Similarly, when I choose an aryl group, let me check my benzene over here. Yes, benzene ring which has been attached to your aldehyde group. Are you getting the difference? So in which we could see that in all these examples, among the 2 valencies surrounding your carbonyl group, one valency has been satisfied by your hydrogen, whereas the other valencies, the remaining valency will be satisfied by your hydrogen, alkyl or aryl group. Is that clear? Okay. Then what is the main thing between your ketones now? Of course, we know your ketones is also a carbonyl group. But what is the major task over here? Yes. So in ketones, what is happening? Both the valencies will be either satisfied by an alkyl or an aryl group. I repeat, in ketones, both the valencies around your carbonyl group will be satisfied by your alkyl or an aryl group. There is no matter of hydrogen over here. Are you getting my point? Very much important. So what is you can say? The 2 valencies around the carbonyl group. 2 valencies around the carbonyl group will be surrounded by yes, which one? Alkyl or aryl group. Alkyl or aryl group. So how can I write it now? In case if it is an alkyl group, I will just take an example. CH3, C double bond O, CH3. It can be. If in case if it is an aryl group, I can write it in this way. That is C6H5, C double bond O, C6H5. I can write it. Yes. So what we are observing, whatever the 2 valencies which were accommodated with that of your carbonyl group has been satisfied either by an alkyl or an aryl group. So this is the major task. Of course, we are going to see the carboxylic acid later in this video, not in this video itself, when we go with the further classes. I don't want to confuse you now. But since now we are going to continue with that of your aldehydes and ketones, first we have to understand and we have to differentiate between aldehydes and ketones. But now the major question arises within us. Of course, sir, you said that when you are talking about an aldehydes, of course the one valency of a carbonyl group will be particularly a hydrogen, whereas in ketones the other 2 valencies of your carbonyl group will be an alkyl or an aryl group. But what is the name of these compounds? Alva, of course I have written a structure. A human being is there, it should have some name. Then only we can call him or we can identify him particularly. So in our next concept, we are going to see nomenclature. Nomenclature. So what we can say in nomenclature, as in the Hindus, we also have 2 names. One is a birth name and one is for calling name. Similarly, in our Organic chemistry also we are having the two names, that is one is the common name and the another will be an internationally recognized IUPAC name. So first and the foremost thing, let us deal with the common name. Common name. So first let me deal with the common name of your aldehydes. How can we name this aldehydes in a common name? Remember guys, whenever we are talking about this aldehydes, basically aldehydes are named by replacing IC acid from corresponding acids with aldehydes. So there is a little bit ambiguity. Don't worry of that one. Let me deal with it. For example, I'm going to write as HCOOH. Of course, I know its name is what? Common name is formic acid. So what I'm going to do, if I want to write its IUPAC name, that is your common name with respect to aldehydes, that is if I want to write HCHO. So of course I'm going to replace this IC acid with aldehyde. That is, I will be getting as what? Form will be there, but instead of IC acid I will be writing as aldehyde. So in common names of aldehydes, they are basically deriving their names from the corresponding acids. So from the formic acid, see how we have got our formaldehyde. Similarly, if I write CH3COOH, what is its name? Of course, it is acetic acid. Acetic acid. But in case if I want to write CH3CHO, how can I write it? Of course, this IC acid has to be replaced by the word as aldehydes. So how will you getting? Yes, acetaldehyde. Getting my point? Similarly, let us go with some different example now. CH3 twice CHCOOH. Basically, I think you don't know its common name. It is called as isobutyric acid. What it is called as? Isobutyric acid. Now, how can you write its aldehyde name, common name? If I have the formula as CH3 twice CH, so instead of COH, now we will be having as CHO. So what you will do? Very good. IC acid, but then aldehyde. So ISOBUTYR, yes or no? ALDEHYDE. So how will you pronounce this? Isobutyryl aldehyde. Yes or no? So by this way, basically we write the common names of your aldehydes. Basically they are derived from the corresponding carboxylic acids by replacing the IC acid by aldehyde. Okay, are you getting my point? So here we give an example, alva. See, HC double bond OH, what it is called as? Formaldehyde. What this is called as? Yes, CH3CHO, acetaldehyde. Will come this afterwards. Okay. Now coming with respect to the ketones. So while naming the common names of the ketones, it mainly depends upon the alkyl groups. It mainly depends upon the alkyl groups which are attached to the either side of our ketonic group. That means what? For example, if I am giving you CH3, COCH3. So its common name will be mainly depending upon what type of your alkyl groups are present on the either side of our ketonic group. So of course now this is what group? Methyl group. So how can I write it? Dimethyl ketone. Dimethyl ketone. Getting my point? Similarly, if I write CH3, COCH2, CH3. Of course, one is our methyl, another is our ethyl. So according to the alphabetical order, ethyl, Yes, methyl. Then comes our the word ketone. So ethyl, methyl, ketone. If I write now CH3, CH2, CO, CH2, CH3. How will I name this? Very good. So it can be called as diethyl ketone. Diethyl ketone. But in case if I am having now C6, H5, CO, CH3. How will you name this now? Yes, of course, this is your methyl. This is our phenyl. So which will come first? Yes, methyl phenyl ketone. Methyl phenyl ketone. So we are getting my point. So when you are writing the common names of the ketones, it mainly depends of what type of the alkyl groups are present on the either side of our ketonic group. I just remembered one thing which I forgot to say when I was dealing with the aldehydes. Okay, coming back with aldehydes, common names itself. So when we of course in aldehydes, in case now if you are having these substituents, okay, in case if you are having a substituent, remember while writing the common names, basically we use the Greek letters. What we are going to use? The Greek letters. Remember why I am saying this, because aldehydes and ketones are such compounds, instead of using the IUPAC names, we are most familiar to use their common names. So in your competitive exams also, there is a less chance that they can give you the IUPAC names. In major cases, what they do is that they give the common names. And whenever it is having a substituent, it is having some specific Greek letters we are going to use. For that reason, I'm just highlighting how to write those common names in case if you are having a substituents attached to your aldehydes. So remember guys, basically the location of our substituents is mainly indicated by our Greek letters. That means the Greek letters, like it may be your alpha, it can be your beta, it can be your gamma, it can be our delta. So first and the foremost thing we have to understand which are these positions. So do remember alpha represents the carbon atom. So alpha represents the carbon atom which is attached to the aldehyde group. It is attached to the aldehyde group. Then of course alpha's next will be beta, beta's next will be gamma, gamma's next will be delta. So let me give you an example. In case now if you are having CH3, CH2, CH, Cl, if I write over here C double bond O and a H. So of course, what did I say? Alpha represents the carbon atom which is attached to the aldehyde group. Of course, now this is my aldehyde group. Yes or no? So now what will be? Yeah, this will be my alpha. This will be my beta. This will be my gamma. In case if I was having one more carbon, it would have been delta. But what is the main thing I require to indicate the substituent? So our chlorine substituent is at the alpha carbon. Are you getting my point? So how can you name this? Alpha, you will be writing hyphen chloro butyraldehyde. Are you getting my point? So alpha represents the location of our substituent. So where is this alpha coming from? The carbon atom which is next to our aldehydic group. For example, let me take one more now. CH3CH OH, and you are having CH2 C double bond O and a H. Yes, of course, now what this will be mine? Yeah, substituent, priority rules. So how will I rhyme this now? Alpha, this is now see in the beta position. Alpha never changes. The carbon atom which is next to our aldehyde group will be represented as a alpha carbon atom. Alpha's next will be beta. Beta's next will be, yes, gamma. So but here the substituent location is at the beta. So how will you name it? Very good. Beta hydroxy butyraldehyde. Butyraldehyde. So no. So beta position mein you're having an hydroxy group. For example, let us take now one more. CH3 here let me take as OCH3, and here let us take as C double bond over H. It is an aldehyde group. So now what it would be? Yes, now this will be our alpha, this will be our beta, but the substituent is at the alpha position. So how can you name it? What is the name of this? Methoxy at the alpha position. So alpha hyphen methoxy propionaldehyde, PROPION, propionaldehyde. Getting my point? So here alpha is the indicating the substituent position. How will you get this alpha? The carbon atom which is next to or which has been attached to that of your aldehydic group. Getting my point? So now we came to know that how to name the common names of our both aldehydes and ketones. Now next important thing we are going to study is with respect to the international recognized names, that is called as what? IUPAC names. IUPAC nomenclature. Very much important. Okay, IUPAC nomenclature. So first let us deal with aldehydes. Okay, you have to pay more attention over here now. Very much important, because they will be having specific rules. For that reason, it is very easy to remember the rules instead of by hearting certain things. Okay. So when I'm talking about the aldehydes and I have to write its IUPAC name, remember what we are doing is we are going to remove E. We are going to remove E from alkane. Okay, from this E has been removed from alkane. In the aliphatic aldehydes, they will be named as, then instead of that E, I am going to add as what? Al. What I am going to add? Al. So what I can get? Alkane will be there. Instead of E, I will be having now Al. So alkanal. Very much easier. What we have done? Instead of E, we have added Al. Very easy. So let us deal with certain examples. So HCHO. I have said you many times how to remember what is the general way of representation of your IUPAC name. First comes the prefix. Okay. First comes the prefix which indicates your substituents. Then comes our root word which indicates, yes, number of the carbon atoms. Then comes our primary suffix. Primary suffix which indicates our saturated, unsaturated bond. That could be a ane, ene, ine. Then comes our secondary suffix. What it represents? The functional group. So this will not change. It will be remaining as it is. But you have to just see whether all of these are present or not. If they are not present, just eliminate them. For example, in the first case, we are not having any prefix. So eliminate it. Go from here. First you write the root word. What is the root word? Number of the carbon atoms. How many number of carbon atoms are there? Yes, 1. So 1 means we'll be having meth. Primary suffix. Of course, there is a single bond. So what you are going to add? Ane. And what is the functional group here? Secondary suffix. It is an aldehydic group. So we are going to use the word as al. So do remember, we have not written this E. These are the silly mistakes we do. Directly what we do, we write it as methanol. METHANEAL. Of course, this will be wrong because you have written E. So very much attention to be paid when you are writing those spellings also. Okay. So are you getting my point? First is your root word which indicates the number of the carbon atoms. Then represents our saturated or unsaturated. Of course, it is saturated. So ane. So from that ane, I have removed this E part and I have written al. Is that okay? Methanol. So this is common name was what? Formaldehyde. So formaldehyde's IUPAC name is what? Methanol. Okay. So now let us take now one more example. CH3, CHO. From where you are going to number? Of course, functional group you should get the least possible number. So do remember, very much important, and there is a slight difference from alcohols. You just signify what is this difference? Yes. Now in case if I was having an alcohol where I would have numbered, I would number on this carbon. Why? Because numbering is always done on the carbon atom. Alva, whatever the numbering we do in the IUPAC nomenclature by selecting the longest chain, it is only done on the carbon atoms. It may be in alcohols, it was in the ethers, there was no carbon atoms in the functional group. But here there is a difference. What is that? In our aldehydes, in our ketones, in our carboxylic acid, of course the functional groups are also having the carbon atoms. So when you are numbering, of course the numbers should be also be representing that carbon atom too. Are you able to understand? See the difference. Here I would have numbered on this carbon, but when the same thing when I am talking about my aldehyde group, I am numbering my aldehydes carbon. So what you are going to get the name now? Very good. So there are first no prefix. So first you write the root word. Of course 2 carbon atoms. So you will be getting as eth. Then it represents your primary suffix indicating your single bond ane. Then comes your secondary suffix indicating our functional group al, ethanol. Yes, let us now add one more, CH3, CH2, CHO. From where are you going to number? Of course from this carbon. Why? Because functional group should get the lowest possible number. 1, 2, 3. So you'll be getting the name as what? Propanol. Yes. Now let's make certain differences. What is the difference? So let me take now CH3, CH, CH3. Let me have here CHO. So just see how can I manipulate this structure. Yes, instead of this CH3 being here, I will just take it over here. So I can write it as CH3, CH, CHO, and I will take here my CH3. Of course, there is no change. Just what I am doing, see, in case if I have added, if I have numbered, what I would done as 1, 2. But when I am taking this structure, of course, even though my aldehyde, this one, what you can say, aldehyde was getting a 3rd position, but here in this structure it is getting the 1st position. That is the least possible number. So this structure is most accepted structure. So 1, 2, 3. You're getting my point. So now you just see, of course, now it is having a prefix, that is the substituent. So first comes the prefix along with the position indicating. So what you'll be calling it as? Yes, 2-methyl. Okay, my prefix I have added. Then root word. What is the number of the carbon atoms in your parent chain? 1, 2, 3. So prop. Then comes your primary suffix, that is your ane and al. So 2-methyl propanol. Getting my point. So let us now deal with one more. CH3, CH, CH2, CH3, CHO. So how can I number this? 1, 2, 3, 4. Yes or no? So I can write it as what now? Very good. 2-methyl butanol. 2-methyl butanol. Okay. So now let us take some halogen substituent CH3, CH. Let me write my Cl. Okay, here itself. Cl, CH, CH3. Then let it be C double bond OH. Enough, alva. So how can you number this now? Of course, the numbering will start from, remember, you're having chlorine, you're having functional group. So of course, our functional group should get the lowest possible number. So 1, 2, 3, 4. So here we are having 2 substituents. One is our chloro, which starts letter with C. And this is your methyl, which starts letter from M. So of course, according to alphabetical order, C comes first. So first we have to indicate the C part, that is chlorine. So how will you write it? Of course, the position is 3. So 3-chloro. Okay. Then -2 then methyl. Alva. So I have completed my prefix. Next, what I have to write? Root word. So totally there are 4. So butanol. So 3-chloro-2-methyl butanol. Butanol. But in case now if you are having like this, let me write it. Yeah, very much important. So do remember guys, it is called as benzene carbaldehyde, benzene carbaldehyde, or simply in many cases we will be using it as benzaldehyde. Benzaldehyde. Why I have given both the names? Because there may be a chance they can ask you this part also. Okay. You should also remember it is also called as what? Benzaldehyde. So benzaldehyde. Very much important part. Yes or no? So let us take now an example in which you are having two CHO groups. CHO, CH2, CHO. So what will be the name of this compound? Of course 1, 2, 3. So there is no prefix. So propane. Yes. But do remember it is having E. Why I am going to say now 1, 3 diol. I have said you many times. If E has to be replaced, the incoming should be what? If it is a vowel. But here it is starting with a consonant D. So therefore propane 1, 3 diol. Okay, 1, 3 diol. Is that clear? Okay. So these are some of the examples of our IUPAC nomenclature of our aldehydes. So coming with respect to our ketones, what you can do with the ketones? How can we play with ketones now? Yes, any idea? Of course, E from the alkane has to be removed and it has to be put as one. So whatever you will be getting, it will be called as what? Alkanone. Yes or no? It will be called as what? Alkanone. So E has to be replaced with O-N-E, O. So let us have certain form, what you can say, examples. So basically let me choose an example, CH3COCH3. Of course 1, 2, 3. So how can you write it as propane 2-O? Propane 2-O. Yes or no? Similarly, if I choose CH3, CH2, CO, CH3, 1, 2, 3, 4. So what you can write? Butane 2-O. Getting my point? Okay. If I choose, now let me take an example where we are having the substituent. Can you please help me out? CH3, CH2, CO, CH, CH3. Let me put here one CH3. So now comes the part. From where are you going to number? Yes, of course I can number 1, 2, 3 or also 1, 2, 3. In both the cases I am getting the ketone is getting the lowest number. So no problem, you can either do it. But do remember, I will choose from here itself. Why? Of course my functional group is getting the lowest number. But there is another rule also. What is it says? Your substituent should also get the lowest possible number. Of course, for functional group, it was not a case. In both the sides, I'm getting 3. But if I come from here, what will happen to this substituent? It will be getting how much? 4. But if I come from here, it will get 2 itself. So, lowest possible number is from this side. So, 1, 2, 3, 4, 5. Yes or no? So, what will be called as 2-methyl. Are you getting my point? See, 2 is written. First, you are writing the prefix hyphen. First letter starts with capital letter. Okay. Then 2-methyl, no space, pent, ane, hyphen, 2-O. Yes, we can write this. Okay. Now let us take now two substituents, CH3, CH, CH3, CO, CH, CH3, CH3. Of course, here no problem, alva. Either ways you can just do 1, 2, 3, 4 and 5. Yes. So what is your name of this compound? Very good. First comes the prefix 2, 4. Then there are two substituents of similar groups. So dimethyl 2, 4 dimethyl pentane. I should have written in one word. Sorry. 2, 4 dimethyl. Then comes your pent. ane 3-one alva 2, 4 dimethyl pentane 3-O. We can write it. If I take two this one ketone groups, for example CH3CO, CH2, CO, CH3. So how can you name this? Of course 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Either ways you're going to get the same number. So 1, 2, 3, 4, 5. Let me select in this way itself. So what will be its name? Yes, pentane hyphen 2, 4. Then I have made a mistake. What is the mistake over here? If I write it as a dione, of course it is a consonant, so I should not remove my E, I should write my E over here. Okay, getting my point? These are the silly things which we miss out. So don't do like this, okay? Pentane 2, 4, dione. Yes or no? But now the question, let us take some tricky one. Okay, once again jumping back to my aldehyde. Okay, till now we have come to know how to write the IUPAC names of aldehydes and ketones. Now let's play certain tricks with our aldehydes and ketones. For example, now if I take CH3, CH3, double bond, CH, and you're having C double bond O and a H. What will be the name of this compound? I'm asking you. Of course, when it was in case of your haloalkanes and haloarenes, the double bond was given the first priority because there our halogens were acting as a substituent. But here, whenever you are having a functional group, I have said you many times, functional group should get the first priority. So 1, 2, 3, 4. So in this, we are having each and every, we are having the prefix, we are having the root word, we are also using a different kind of a primary suffix, and also we are having a secondary suffix. So how will you write it? First indicate your substituent. So we will be having 3 hyphen capital letter methyl. Okay, I finished my prefix. Then root word but. Now here we will not be getting as a ane. Instead of what we are going to get? Ene. So but hyphen indicate the position 2 hyphen en. That's it, because whatever we are adding will be a vowel. So we have to remove that E. So what you'll be getting? 3 methyl but 2 ene all. Yes or no? I solve. Okay. Let us take with a ketone example. Let me take as CH3, CH3, double bond CH, 1, 2, 3, yeah, C. Let me take over here my ketone group and CH3. See whether all the valences are balanced. Since it's my example, okay, it's balanced. Okay, so okay, now here what you're going to do, of course, here also ketone is a functional group, so it should get the least Poisson number. So 1, 2, 3, 4, 5. So what is the name? 4 hyphen capital letter M methyl pent 1, 2, 3, 3 hyphen ene. Then comes what? In the second position you are having the ketone group, so indicate that position 2 O. Very much important. You are getting my point. See how much accurate we are. In case if you are not having this structure, can you write the same thing by having this name 4 methyl pent 3 ene 2 O? Of course we can write it. So whenever you are writing the IUPAC name, I will just give you the hint. Once you have written the name, by utilizing that name, you only try it once to write this structure. Then you will come to know whether we have written right or wrong. Okay, this was my protocol when I was in PUC. Okay, because all the times nobody is 100% sure. We have to analyze our own answer before submitting it. Okay, so once you have written the IUPAC name, you only write without seeing the structure what they have given in your question paper, you only try that structure. But when you have to try, after finishing your all answers, okay, don't sit in the middle and try for the answer. Don't waste your time. Okay, first you complete as much as early it is possible. Then when you are glancing the answers once again, you just try it. That will be giving you 100% assurance that whatever we have written is correct. Is that clear? Okay. So this is one part, a tricky question. But now let me give you one more question. What is that, sir? If in a structure you are having both ketone as well as your aldehyde. What I'm saying, you're having both CH3, you're having CH2, you are having C double bond O. Okay, one ketone group is there. There is CH2, C double bond O and a H. Okay. So in this example, we are observing they are having the two functional groups. Yes or no? So now what you are going to do? What you are going to do is my question. Yes. So here comes the game of priority. Okay. So when we consider your ketone and aldehyde, of course our aldehyde will be having the what? Higher priority. So one group which is having the higher priority, it will be acting as a functional group. The group which is of the lowest priority, that will be given as a side chain. That will be given as a side chain. So when the functional group acts as a side chain, it is having an other name itself. Alva. So when your ketone was acting as a functional group, we use the keyword as what? One. But now when it is acting as a side chain, it will be having the keyword as oxo. In your first PUC, we have dealt with it. So of course, now from where you are going to number 1, 2, 3, 4, 5. So 3 hyphen oxo. Getting my point? 3 hyphen oxo. What are you going to write? Pent. Pent, we are going to write pent. Then we are having enol. Alba, 3-oxopentanol. Yes or no? 3-oxopentanol. Getting my point? And till now, okay, these are keeping it aside. Now let us deal with some interesting part. That is, I wanted to just show you one important thing over here. What was that? Remember guys, when I was talking about my prefix, in my earlier videos I have said you that this prefix is once again given as a primary prefix and a secondary prefix. So basically your primary prefix, as usual, it indicates our substituents. That's not a matter. What does this secondary prefix indicates? So basically this secondary prefix comes to existence whenever you are having a ring structures. For example, let me take this structure. Double bond O and a CH3. Yes. So till now whatever we have seen was a straight chain, branch chain, everything we have seen, but this is somewhat different in which you are having a cyclic structure. Remember, our secondary prefix indicates the cyclic structure. That is by the word called as cyclo. So first, of course, now you're going to number from here 1 because it's a functional group. 1, 2, 3. So primary prefix will be the indication of our substituent. So you'll be getting as what? 3 hyphen methyl I have got. Then comes this secondary prefix. What does it indicate? The cyclic structure by the word called as what? Cyclo. What it is called as? Cyclo. Then as usual, total number of the carbon atoms 1, 2, 3, 4, 5. That is your root word. Pent, ane and an one. Are you getting my point? So this is what I wanted to just show you. Okay. Because till now whatever I have given you was directly I have given you prefix. But since this is one structure which exists, so we have to come to know that even prefix is also divided into two parts. Primary prefix, secondary prefix. Primary prefix indicates our substituents, whereas secondary prefix indicates the cyclic nature. And in that cyclic nature is mainly indicated by a word called as cyclo. We are mainly using this word as a cyclo. So let us now have one more formula structure. Let us take this like this, CH3. So what are you going to do? Of course now 1, 2. So first you write the primary prefix 2 hyphen methyl. Next secondary prefix. What is that? Cyclic ring is there. So it is your cyclo. 2 methyl cyclo hexanone. Hexanone. Remember, if you were having this part, benzene ring idre, we are not using the word as a cyclo. Other than the benzene ring, any structure, for example, if the same structure was in this way, that is if I take here, double bond was a double bond O, CH3. So like this was there, what you would have done, of course the numbering will start from here, 1, 2, 3, 4 and a 5. Yes. So of course now 2 methyl cyclo hex, yes, 4 ene one. So like this represents your cyclic ring, not your benzene. Benzene bandaga now yavatu cyclone use madala. Other than the benzene ring or aromatic rings, yavade one ring bandru kuda, ಆ ಒಂದು ಸೆಕೆಂಡರಿ ಪ್ರಿಫಿಕ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವೇನಂತ ಆಡ್ ಮಾಡ್ತೀವಿ, ಸೈಕ್ಲೋನ ಆಡ್ ಮಾಡ್ತೀವಿ. Is that clear? So this completes the today's video of how to name your aldehydes and ketones both in our common system and also in our IUPAC system. Okay, practice, then only you'll be having any doubts, it will be easily clarified. Okay.